Howdy everybody in YouTube land. The Delta Gold XT is back on the bench. Why is it back on the bench? Well, when I was working on a 386 board, I don't have any VGA cards, so I pulled out a monochrome card and it didn't work. The monitor would just show a bright raster and that was it. So I figured, well, I know this worked because I last did a YouTube video on it, I don't know, 8 years ago. So I know it worked. So I pulled it back out and plugged it in so I can make sure the monitor still worked, because you never know with a monitor. And this is what happens. The internal video card died, because that error notification means this is not being detected. So we have to find out what happened. And the only thing that's changed is time. So something went bad just sitting around. Now that I got this big behemoth of the board out of the Delta Gold, we need to find out what's going on with it. So this section here all appears to be related to video in parallel, so that's where I'm going to start. The floppy controller, the hard disk controller, which is not part of this board, but the floppy controller and all that stuff worked. So I'm going to ignore that for now, but we have the RAM here, which I'm thinking about removing and sticking it into another MDA card and see if, yeah, that. So I'll try that first. But another thing I've noticed as I'm working with this board, it's got this like mesh type of coating on it. It's weird. But on top of that, there's a little bit of corrosion here I saw that I had to clean up a little bit. You can kind of still see it there. So that has me concerned. At least it doesn't have a Varda. No, this is OEM. This is stock, I'm pretty sure. So, yeah, it is. The other thing I'm noticing right away, too, is I'm looking at the video circuit, and I saw this, too. So this, yeah, I'm going to have to check that. There's the 3 capacitors I replaced when I worked on this in 2014. There's a blob here. I don't remember why or what that's about. So yeah, it's just next plan of attack really is to pull these RAMs and put them on a different card and see if it's the problem with the RAM, because I don't have any replacements yet. So I took the RAM off and put sockets on there. So what I did was I took that RAM and put it on this card and tested in a different board. Made the error beep go away. So that RAM is probably fine. It made the error beep go away, but this card still didn't work. Now, granted, how the original RAM looked on this card, like, see that? And the fact that the socket kind of looks like that, with the burnt pin in the middle, and you can see the melty marks. I don't think this card's any good anyways. So, it used to work, but, you know, I'm sure it's dead, so I'm going to rule that out. But I tried this RAM on that card, and the error beep did go away using a different board. Not this board, but it did with a different board. This board, it's not going to, because this is sitting in the decode space. So this would have to be entirely disabled before I can put another Hercules card in here. So from what I found online, I cannot find a datasheet to this chip. Taiwanese, not surprised. Can't find the datasheet to that. It was probably in a book somewhere, long gone. But what little information I did find out is what this does is it extends bitmap display Hercules support to this 6845. Now this 6845 is well documented. RAM access from the system is arbited through this chip and these 4 muxes. So the reason why I'm pointing this out is because the BIOS is designed, it will go beep, beep, beep if it can't read and write this memory. So this chip could be bad, or any of these muxes could be bad or stuck, or any of these PALs could be bad. It's really a crapshoot at this point. Now, the next line of defense at this point is pulling the muxes. I don't have a schematic, so it's not like I'm going to be able to go with a logic probe and, okay, well, this bit's stuck, or this bit's not following this bit. Again, it's a mystery board, so I'm going to need to pull the muxes and check those independently just to rule those out. I'm probably going to end up pulling all of these logic chips and checking them. And if all of those are good, the only thing left is this 6845. And if failing that, then one of these is bad, and then it's game over. So I checked those 4 muxes. Just soldered them back in. I checked those 4 muxes in my tester, and they're good. Now, I'm using a TL8662 programmer, which has a logic test function. And these 4 came back, because I've seen these go bad in the SD30. That's why I went ahead and checked it, because those are the muxes for the RAM. The next thing I want to do is I want to check these here and see if those are good, and if they are or not. If they're still good, I doubt the PALs are bad. I don't know if I've ever ran into one that was bad before. But if those test good, then the only thing left really is one of these 2. That's it. So let's move on. Alright, well, it's time to check the rest of these. Alright, so I checked the rest of the logic chips. They're all good. I didn't have this one in the database, but it's probably fine. And then this one's not in there either. But, and the trouble with this is I can't find reference designs on any of this stuff anywhere. And I've seen online pictures of ISA cards that have the exact same chips on it, Hercules boards, and I mean, it's almost like all of this stuff was locked away in a vault somewhere and then burnt in a forest fire. I don't know, but I can't find any data on it. So really, it's I can find a lot of stuff on this, but that's really it. So what I've learned, though, from the little research I've been able to do is memory access is switched between here and in the main bus through these muxes. Now, the way the ROM works on this, from what I understood, is when it's in monochrome mode, which is what it is set in, it tries to read and write this memory, and if it fails for any reason whatsoever, it throws that beep code, and that's what's happening. So there could be 3 causes for that outside of bad RAM, and I checked that, and that's not the case in this board. So it's either the muxes are not selecting properly between, you know, the system bus and the rasterizer from this chip here, and that could be the high order address bit decoding network that's in the PALs, or 2, it could be the low order bit addressing, which is when within the RAM select area, one of the, like A0, A1, A2 is stuck here, or for some reason or another. The third thing it can be is the data bits are stuck low or high for some reason. I don't know yet. Now, what I'm going to try to do is I'm going to take a look at this logic. I was going to use this logic probe and look at some signals to make sure the mux is selecting and things like that. Now, this is the equivalent of like the idiot light in your car. I mean, it's not going to tell you much other than that there's something there. Now, if you want to really get down to the nitty gritty and see if the system bus that's writing to this address is able to read back from it, you need a logic analyzer, which is not something I really have right now. So I've got to really take a stab at the dark at this. So my shotgun approach didn't work here. So the only thing left is these 3 chips here. This one, this one, and this one, or one of these 2, or one of these being bad. I don't know. So I'm going to have to go at it with a logic probe. Alright, so I got done playing around with the logic probe. It didn't tell me much, but at the same time it told me quite a bit. So, 1, the muxes are switching and doing what they're supposed to be doing. So that circuitry works, and that's responsible from these guys. Also, the DRAM data lines 1 through 4, each RAM is 4 bits, will power up in a random state, sometimes zeros, sometimes stuff in there when I first power it up, indicated by the logic probe. But the one thing it does tell me is the row address, column address is coming online and doing its thing like it's supposed to, and it's reading out continuously whatever random bits of data are in there. Okay, so the other thing it's telling me is the right strobe, which is an active low signal on this RAM, is staying high until after the error beep occurs. When the error beep occurs, it goes low, and then the DQ lines will change. So if I reset the system, the DQ lines will affect whatever was written in there during the write strobe period. So the RAM is working. But at the same time, the error is occurring before it even ever tests the RAM, because the write strobe never goes low until afterwards, which means the logic circuit has to be working because the write strobe does go low eventually, but not during the test when it throws the error. So what that's telling me is the BIOS, even though the generic error code says unable to write RAM, is not true. The BIOS is doing something else that's throwing the error from the video circuit. So the machine does boot off the hard drive, so I know the machine works. So the error was it's probably trying to write to the configuration registers in one of these chips, and that's throwing the error. Because apparently this particular chip here, the the 6845, has registers in there that are written to control this chip. So if this thing is trying to write to and read from a register and there's a problem with that, it could throw the same error. I don't know. But it's not making it to the RAM check before it throws the error. This is a mystery chip, so I don't know if that's being written to or not. So I'm going to go pull the data on this chip, but I'm thinking it's bad. So moving right on down the chain, what I've discovered so far is this chip here is working, because I'm watching the BIOS put data into this chip, and then towards the end, when it gets to the error beep, it turns on. So looking at the timing information coming out of this chip, and this chip is fully programmable. The BIOS has to tell this chip what to output, because this is a timing generator. So looking at the timing, it's going into text mode, but the timing is not making it out here. So something in between is screwed up. And the only thing I can think of is this guy here. So just moving on down the line, now I'm up here. And unfortunately, this PVC2, I can't find any data on it. This is a custom chip. So I'm wondering, I'm checking the these logic chips here. My programmer doesn't have a test for that, but this guy seems to be working so far. So let's move on down the line. So I did some quick checks at this MUX. And this MUX is held high. It's never turned on, or it turned the other way anyways. And then when the system comes up, I can see the video signals at this MUX, which are supposed to be over here, but this MUX actually switches it off. The control line for that MUX goes to two places. One, it goes to this pin over here, which is an input on the PAL, but it also goes to this pin over here. So the video signal is turned on by this guy here, so it's not, this chip is not turning it on. So I'm starting to lean towards that chip being defective. Well, I don't know why I didn't think of this before, but when I was doing some more probing with the logic probe, I graced my finger on this chip and it burnt. This chip is getting red hot. I don't know why I didn't think of that before. Why didn't I just feel the chip? So, yeah, yeah, it's bad. For the sake of testing, what I've done was removed that. I removed all of the PALs, and I removed the RAM, and I put the RAM on this card. And now when we power it up, hey, what do you know? No error. Yep, so let me go get... I don't think this card's any good still because this doesn't output anything. But let me go get the monitor anyways. So what we know so far is Paradise has been lost. So this chip is bad for sure. If it wasn't bad before, it definitely is now. So, but I can't find any data on that chip. However, I've been posting a Twitter thread as I've been working on this board. The video always comes out later than the Twitter thread. And someone had pointed out to me that the Commodore PC-1 uses the same video hardware. So if we take a look at this schematic right here, there is our PVC2, and there it is in the chip, in the schematic. Again, we still don't have a data sheet, but what we do have is the labels of all the controls, the pin numbers, and how they're used in the circuit. So this is a 6845 and PVC2 combo, which is capable of doing color graphics because there's the red, green, blue. Now, this board does not use color graphics because the color switch is not enabled. It's set for monochrome. So, but it's got a very similar circuit, and as you can see, we're using PALs. Also, this first page here is the parallel chip PPC1, which is that guy there. So it's basically the same design. So we take that and put it off to the side. But we have a PAL network here. So we have, let's see, we got 5 PALs here. And this circuit here, I mean, obviously it's not going to be the exact same design because Commodore kind of did their own thing. But at least we can kind of see what's going on here enough to where we have this. We have this MUX, this 257, which is here, 257. Looking to see if there's anything else. No, that's the only 257. So the signals from here and here are gated through this 257, which makes sense because we have this 257 here, but we also have a 244 there, which, if we look there, there's a 244 because pin 40 is up here. And the control lines go right into these connections here, which if we look at this schematic, there it is. 40 is the composite video output. So pin 40 would run off to wherever the hell it's running off. But at least now I have a frame of reference to determine what's going on here. So now, looking at this. So this thing throws the beep, beep, beep code. What about this chip will the BIOS do or use to determine that this circuit's not functioning properly? I'm looking at the data lines here, which goes off into, page 11. So if we take a look at page 11, this is another one. This is the dip switch for the video settings and stuff. So I'm going to set that away. So if we look at 11, so if we have this chip here, D0 through, let's see, where was I? D0, video memory data. So VMD, it's coming on the other side of this. Okay, so the data lines go directly into this chip. Now, if this chip was holding up the lines, it'd cause problems, but it's not because I removed the chip, right? So, what else? What else on this chip can the BIOS monitor to know that there's a failure to throw the code? I don't know. I don't know how the BIOS works enough to understand what it's doing to know that there's a fault in the video circuit. So it's not a RAM problem because it never tests the RAM, as we saw earlier. It throws the code before it even enables the RAM. So, and then once it throws the code, it turns this chip on too. So this chip is working. But my question is, how does the BIOS know that this chip is missing or bad? What I'm getting at is here, are there any other bad parts that could be throwing the code? Because if this chip is removed, I don't know. Obviously, the video circuit's not going to work, but it shouldn't throw a code from what I'm looking at here. There's an LP enable, which I don't know. I was trying to see if there's registers in this chip that can get programmed. Horizontal drive, video address 0, something, CPU AD. CPU AD from 11. Select. Now, The processor might be able to talk to this, and because it's not able to talk to this, it's not working. I don't know. If anyone has any comments or thoughts on this, leave it in the comment section, because I'm not 100% experienced with PC XT video circuitry. So, but I have to wait for this chip to come in anyway, so I think I want to end the video here. So if someone has any advice or anything, let me know in the comment section below. In the meantime, thank you for watching. And feel free to leave a comment and subscribe, like, and all that fun stuff. Until next time, guys.